Elon Musk just merged his AI company with his rocket company, creating a $1.25 trillion company that is aiming to put 1 million data center satellites into space. In this episode, I'm going to dig into the financials behind this deal, the skeptics who think it's a bailout dressed up as a big vision, and the people who really believe in this and believe it's going to be completely transformative. Now, what I really want to do with this is use it as a topic to explore, the historical patterns that this move highlights, and how industry and production always follow the cheapest energy source, from textile mills moving to coal fields to data centers, even hydroelectric dams today. We're going to look at the Kardashev scale, the idea behind the Dyson sphere, and the concept of a civilization harvesting its star, and whether AI's growing energy appetite is the thing that's going to finally push us to move infrastructure off planet. This is In the Loop with Jack Horton. I hope you enjoyed the show. So I think let's start with the merger and context. So many of you will have heard about these companies. On one hand, you've got xAI, which is obviously the AI company that Elon Musk started, which is basically ChatGPT, but accessible via Twitter or X and API. So it's the one behind many of the scandals that are enabling people to put in a picture and say, turn this person into the same person, but wearing underwear. And of course, everybody knows SpaceX is the rocket company. And this really sets the scene behind this big merger, because a single query to a large language model consumes roughly about 10 times the energy of a single Google search. So if you scale that to, say, billions and billions of queries happening every day, and the picture, obviously, from an environmental perspective, could get quite uncomfortable quite fast. The International Energy Agency actually found that global data center energy consumption hit about 415 terawatt hours in 2024, which, to put that into context, is about 1.5% of all electricity generated on Earth. And by 2030, this same agency, the International Energy Agency, actually believes this number will be more than double to nearly 1,000 terawatt hours, which is slightly more than Japan's entire national electricity consumption as it is today. And Goldman Sachs actually estimates that power demand is going to surge equivalent to adding another top 10 energy-consuming country to the planet. And that's before you account for the growth trajectories everybody keeps revising upwards. So it's in this context that about 10 days ago that Elon Musk announced the merger of SpaceX and xAI, creating what the company called one of the most ambitious, vertically integrated innovation engines on and, importantly, off Earth. The combined company is valued at about $1.25 trillion, with SpaceX at roughly $1 trillion and xAI at about $250 billion. So this is by several measures the largest ever merger in history, and it's all being driven by demand and need for AI. And the financials underneath all of this, to be honest, is just bonkers. SpaceX generated about $15 billion in revenue last year, with an estimated $8 billion in profit. And Bloomberg has reported that xAI recorded a loss of about $1.46 billion in September alone. And they're only making about $107 million in revenue. And that revenue itself has been questioned, because revenue did double last quarter, but it would need to double about 4 more times to catch up with their burn rate. And the quality of that revenue is again questionable, because a lot of people are complaining that actually what they're calling LLM revenue is just advertising revenue on Twitter. Days before that merger announcement, SpaceX filed an FCC application form, which basically allowed them to apply to put 1 million AI satellites into low Earth orbit. And to really understand what that means, consider that there's about 14,500 active satellites around Earth right now. So obviously, that is a huge leap in the number of satellites in low Earth orbit. And what the actual application described is a first step towards becoming a Kardashev Level 2 civilization, one that can eventually harness the power of the sun to fuel energy demand. And SpaceX has also argued that orbital data centers would be cheaper and more environmentally friendly than those on Earth, with satellites venting heat into, obviously, space, which is extremely cold, and harvesting solar energy without any clouds or atmosphere in the way. And of course, Musk's claims go even further. He said that, and I quote, "My estimate is that within 2 to 3 years, the lowest cost way to generate AI compute will be in space." So when I say compute, by the way, or people say that in the news, it's basically the way we generate energy to produce computing power. And looking long term, he described lunar manufacturing as a way to deploy about 500 to 1,000 terawatts of AI satellites into deep space orbit every single year. And again, remember the needs of, say, Japan is about 900 terawatts of energy. And if they manage to do this, it would be thousands more gigawatts of energy than exists on Earth. Now, obviously, not everybody's buying this. You know, there's people like investor Ross Gerber offered what became one of the most shared tweets or reactions on Twitter, saying basically X was out of money, so it merged with xAI. xAI was then out of money, so it merged with SpaceX. SpaceX is going to run out of money, so it merges with Tesla. And when they're all out of money, they're going to go to the public stock market for a huge fundraiser. And it's interesting because SpaceX didn't explain how xAI would actually contribute to orbital data centers beyond being just a customer, arguing that really the move was quite financially motivated. Because ultimately, Musk, with xAI, faces the same funding challenges as any startup leader in the AI space. You're competing against Meta and Google and their advertising business model. Because ultimately, what Gary Marcus said in his Substack was, by trading xAI, say, thousands times their actual revenue, when they're in an increasingly crowded field where everyone is forced really into a price war, seems crazy. And behind a lot of this sits the IPO question, because SpaceX is reportedly targeting a mid-June 2026 IPO, and it's supposed to be probably one of the largest IPOs ever in history. And so many people are saying that this is less about orbital space centers and more just about trying to create a very attractive entity, essentially, for that public listing to generate the most cash. But I mean, obviously, optimists have arguments too. You know, Tom Nash pointed out that when SpaceX talks about infrastructure, history suggests that everybody should really be listening, even if it starts with what is very uncomfortable, unrealistic ideas at first. And a good example of this is Starlink. When SpaceX began launching internet into space, the economics obviously didn't work. But since then, the cost to launch has dropped from 20-fold to very, very affordable. And now Starlink has over 9 million global subscribers, generating about $10 billion in revenue. So the thing that everyone said was impossible became possible. And this is where I think the really interesting historical comparison can be made. And as you know, if you've been listening to the podcast on a regular basis, any opportunity to make historical parallels is always quite fun, because it does tell us whether this is likely to succeed, to be honest, or likely to gain more and more momentum. Because before we say anything or mention orbital data centers, the pattern really is held for 250 years that says, yes, we will end up in space to generate energy and computing power. You know, look at the late 18th century. So textile mills in England started out at rivers or just around rivers. They had access to water wheels where that was the only real source of revenue. And the Pennine valleys north and east of Manchester were fantastic for this. You know, had lots of free-flowing streams that drove cotton production. Then we saw the steam engine change everything. Suddenly, mills didn't need rivers, they needed coal. And so they moved. By 1802, Manchester and places like Salford had more than 50 steam-powered mills drawn there by ready access to coalfields in Lancashire. The same pattern played out in the 20th century with aluminium smelting. You look at data centers, Microsoft has operated a huge campus in Quincy in Washington since about 2006. And this place has no particular reason to exist as a technology hub except that it sits downstream of a huge dam where obviously hydroelectric power is among the cheapest in the country. And Intuit, Yahoo, Vantage has followed Microsoft to the exact same place. So the need to generate energy is getting crazier and crazier. And in 2024, Microsoft even signed a 20-year power agreement to restart a nuclear power plant. And Amazon and Google are doing the exact same. Trillion-dollar companies doing what governments used to do, just to generate energy for data centers. And so obviously this is the context that makes this space argument really interesting and attractive to investors and SpaceX and just the entire world, quite frankly. because solar energy in orbit is about 8 times more productive per unit of panel, so solar panel, than on Earth, because there's no atmosphere absorbing radiation, no night cycle, no weather, and no seasonal variation. But obviously that doesn't mean that this is easy, because the engineering challenges are huge. Like, latency is real. Even in low Earth orbit, you're adding about 20 to 50 milliseconds of a round trip of sending energy and information, which obviously rules out any real-time applications. And radiation also degrades electronics. So maintenance means sending robots to space, not technicians. And the manufacturing scale to produce 1 million satellites doesn't even exist on the world yet. And to put that into perspective, SpaceX currently launches about 2,000 satellites per year. So just imagine what sending 1 million satellites to space would require in terms of production and then launching it. It's close to science fiction, but it's also believable as a vision. So yeah, I think this pattern holds. Industry has always followed the cheap energy every single time, without exception. And the question isn't whether that continues to me. It will continue. The question is whether and when that next migration is going to be upward to space. I mentioned it before. Personally, I believe that if we're to survive as a society and exist in the future, we need to do that. We need to take that leap. We're killing the planet. Even when COVID shut down most of the world, we were producing far too much CO2 emissions to even hit the Paris Climate Agreement targets. And so I don't really believe it's possible to reduce our emissions fast enough. And that's not me saying we shouldn't try to, or we shouldn't be more efficient. I've been a vegetarian for over 10 years. I don't own a car. But I do believe we obviously need to find solutions that are extremely ambitious. And I do believe we have to do that fast. And I also believe that AI has a huge role in that process. And this really is where that Kardashev vision of society comes in, and why I think it's a very interesting topic. And the fact that it's been referenced by SpaceX is even more interesting. So let's just discuss that just for a second. So in 1964, a Soviet astrophysicist named Nikolai Kardashev published a paper in which he proposed classifying civilizations by the amount of energy they consume. And so a type 1 civilization harnesses all energy on its planet. A type 2 will harness the entire output of its star. Type 3 will take all the energy of its galaxy. And apparently, according to Carl Sagan's formula today, we roughly sit at 0.73 on that scale. So not even type 1 yet. And people predict that we might reach type 1 officially in about 100 years' time. And so obviously what makes that SpaceX filing very interesting is, regardless of what you think of the company or of Elon Musk, it explicitly quotes that framework to move to that type 2 civilization. And what they're really alluding to in that submission and that application is a Dyson sphere, which Freeman Dyson had already described what a type 2 civilization infrastructure might look like. But essentially, he described this technology, which is essentially a swarm of objects around its star to capture its total energy output. And he later clarified that a rigid shell obviously was just impossible, but if you had swarms of objects traveling in independent orbits around the sun, sending energy back, that would be a way of harnessing the sun. And obviously that's SpaceX's vision here, 1 million solar-paneled AI satellites orbiting Earth, and then eventually, of course, as it said, to reach a Type 2 civilization, so the same but for the sun. So yeah, I do think that it feels exciting, it feels right. Whether it's overly ambitious, whether it's just for money, whether the companies are dying, I don't know, it's hard to tell. But regardless, taking a step towards unlimited clean energy is probably always a good thing. I personally believe in that importance of becoming a Type 2 civilization before we kill ourselves off. Anyway, let's conclude and wrap up. Obviously, as we spoke about, every single query you send to an AI model, every image generated, every agent running in the background is consuming loads of energy. And collectively, these queries are creating a demand curve which is going to double by 2030, and apparently is the same as adding another country to the energy grid, a top 10 country in terms of energy consumption. And this SpaceX filing and the merger with xAI speaks to either a vision of the future or being completely delusional. And the honest answer is that we just won't know for years. You don't have to like the person proposing it. You don't have to like the company. I certainly would never own a Tesla, for example. But ultimately, I do believe in that future of the planet. Anyway, thanks for listening. I hope I'll see you next week, and I hope you enjoyed today's episode.